Hello, friends. Today we are going to start our math lesson on equivalent fractions, and that's called 4.3c. This is also called Lesson 3. So let's take a look-see and see what we're going to do today. Today, you will determine if two fractions are equivalent. So we want to know if these two fractions are the same amount, even though they may not have the same number of pieces. So let's see what we have in store for us today. But before we start, let's do a little number talk on the identity property of 1. Yes, that's 1. So let's see what that is all about. When I look at a fraction, I'm going to take a look at one whole piece. This is one whole piece. These are two whole pieces. I just want to work with one whole piece right now because I want to know what this identity property of 1 is. Because when I have 1, I can divide it up into different pieces. For example, if I have one whole, I can divide it in half. So this would equal 2 out of 2. If I have one whole piece, I can also divide it into thirds, and it would still be one whole piece, but divided into 3 parts. Let me pick a different one. What about the fifths? 1/5, 2/5, 3/5, 4/5, and 5/5. This still gives me a whole number, one whole number. So one whole is equal to 1. 2 wholes, 1/2 plus 1/2 is equal to 2 halves, which is equal to 1 whole. Here I have 1/3 plus 1/3 plus 1/3. It gives me 3/3. And guess what, friends? It's still equal to 1 whole. Here I have 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. And that is equal to 5 over 5, or 5/5. And yes, you guessed it, it is still equal to 1 whole. So what I want you to get from this is that many times we're going to have to take that 1 whole and make it into a fraction. But we don't want to change its value. We're just changing the number of parts. For example, here with the 5 over 5, I have 5 sections, but when I put them together, they still equal my 1 whole from up here. And this is the identity property of 1. Now, can you think of any fractions that equal to 1? Write them down and check to see if they follow this pattern, because this pattern is where you have the numerator and the denominator with the same digits. 5 as a numerator, 5 as a denominator, 5 over 5 equals 1 whole. 3 as the numerator, 3 as a denominator, that equals 1 whole. So this is our number talk. Okay, let's move on to task A. And remember that we are trying to determine if two fractions or more, they could be 3, are equivalent. If they're equivalent, that means they're going to have the same amount. They will equal the same amount, but they won't be the same number. They'll be the same size and they'll be the same portion, but they'll have a different numerator, different denominators. Why do we even have to figure out equivalent fractions? Well, fractions tell us and they show us what portion of a whole you need. They show us the portion of a whole that you have or that you want. Fractions are used in baking when you're making food and cooking. Fractions are used when you're telling time. Perhaps it's half an hour that you're going to be working on this. It's used in sports and food, even in shoe sizes. You might be a 7.5 or a 5.5. And it's used when you're looking at miles, when you have to run 3.25 miles. But this is task A for you. And I want to ask you this question. Are these two fractions equivalent? 2/8. So let me look for my eighths. And 1/4. So take a look at this right here and check to see if you think that these fractions are in fact equivalent. This is 1/8 plus 2/8, which equals 2/8. And here I just have 1/4. Now I notice that these numbers are very different. How could they be equal? But when I look at this amount, I see that this amount seems to be the same amount shaded over here. So these fractions are equivalent. What would be a different way for me to find out if they're equivalent? Can anyone think of a different way to check to see if they're equivalent? If you do, please write it down. Okay, friends, I'm going to ask you another question. This is now task B. I'm going to ask, what fraction is equivalent to this fraction right here? There and there. Which fractions are equal to this fraction up here? Well, let's see, I have 1/4 plus 1/4, and that is equal to, what do you think? Yes, 2/4. I want to keep my denominators the same, fourths, and fourths when I'm working with this section right here, and there are 2 of them. Well, can you tell me of a fraction that is equivalent to 2/4? And tell me how you know. So can you please pause the video and write down a fraction that you think takes up the same amount of space as 2/4, even though it doesn't have the same number of pieces in it. So pause it, write it down, and then press play. Okay, now that we're back, what do you think? What do you have here? Did anyone pick a half? Yes, because 1/2 is equivalent to 2/4. If I was to put a half right here, it would fill it up perfectly. So that's why they're equivalent. Let's think of another one. Can you think of another one? What about the eighths? If I put one here, that's 2/8, 3/8, 4/8. Should I put one more? No, I better stop there. So what's 1/8 plus 1/8 plus 1/8 plus 1/8? 1, 2, 3, 4. Yes, that equals 4/8. 4/8 is again equal to 1/2. Did you think of another one for this one? Because we really want to make sure that we get them all in here. So what do you think? Did you think of one? How about the 6s? Let's try the 6s. How about 1/6 plus 1/6 plus 1/6 plus, what do you think of that? Too far? Yes, I'm going to trash that one. So 1/6 plus 1/6 plus 1/6 equals 3/6. And yes, that too equals 2/4. So all 4 numbers here are equal to 2/4. They are equivalent. How do I know they're equivalent? Well, because these all take up the same amount of space, whoopsie, which is half. And I can tell that it's the same amount that's taken up, but it's not the same number of pieces. I mean, here I have 4 pieces, here I have 2, but they still take up the same amount, same size, same portion. That's why they're equivalent. Can you think of any other fractions that are equivalent? Write them down in your math journal, and you can pause it Then you can press play. Okay, friends, I'd like to show you a short video about equivalent fractions from our district here in Pasadena ISD. So let's listen to see what they have to say.
Let's determine if 1/2 and 2/4 are equivalent fractions using two different strategies. Each circle represents one whole. Let's partition the first circle into halves, 2 equal parts. Here's 1/2, and here's another half. Let's represent 1/2. Let's partition the second circle, the second whole, into fourths, 4 equal parts. 1/4, 1/4, 1/4, 1/4. Let's represent 2/4. It looks like 1/2 and 2/4 are the same size and they cover the same portion of each circle. Let's check by placing 2/4 on top of 1/2. When I placed 2/4 on top of 1/2, it showed that both covered the same area, the same portion of the whole. That means that 1/2 is equivalent to 2/4. Let's try another strategy to determine if two fractions are equivalent. I'm going to use Cuisenaire rods, but you can also use fraction strips. The brown rod represents one whole. 2/2 are equivalent to one whole. Let's double the number of fractional parts by using the red rods to represent one whole. Four-fourths are equivalent to one whole. We went from 2 fractional parts to 4 fractional parts. The number of fractional parts equivalent to one whole have doubled. Let's represent 1/2. Let's represent 2/4. I can see that 1/2 is equivalent to 2/4. I can use the identity property of multiplication to verify if my fractions are equivalent. I started off with 1/2, then I doubled my fraction, or multiplied by 2, and it is 2/4. 1/2 and 2/4 are equivalent fractions.
Okay, boys and girls, so we saw that quick video about equivalent fractions, and they even took it a step further and used the identity property of multiplication of 1. I want to pose a question to you. I'd like to ask you, are these fractions equivalent? So you're going to answer yes, they are equivalent, or no, they're not equivalent. So far, what do you think? While you're thinking, I'm going to count these to put the fraction down. So this is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. So I'm going to write that down because I don't want to forget. I want to see the fraction tiles, and I also want to see the fraction number. How about this one right here? 1/12, 2/12, 3/12, 4 5 6/12, 7/12, 8/12, 9/12. 9/12. You know, just by looking at the numbers, these numbers are different. Here, there's 9 pieces, and there's a 12 on the denominator. And here, there are 6 pieces, and there's an 8 on the bottom part, which is called the denominator. You know, friends, but when I look at this, it just looks like it's the same amount. It looks like it's the same value for both of them. So in my brain, I'm thinking, there's no way these two numbers, fraction numbers, are the same, but they are equivalent. They're equivalent because they have the same value. Now let me ask you, what other fraction equals or is equivalent to 9/12 and 6/8? Pause for a second, write it down, and then press play again. Okay, so what did you come up with? How about the fourths? Let me see if this works. 1/4 plus 1/4 plus 1/4. Looking at the amount, it looks like it's the same amount, and if it's the same amount, it's going to have the same value. Let me write down my fraction here, and it's 3/4. These three fractions are equivalent because they have the same value. They don't have the same number of pieces or portions, but they do have the same amount, which is why I think that these three fractions are equivalent. Whew, that was a lot of work. How about we play a little game of concentration, fraction concentration. So this is what I'd like for you to play for a few minutes to see if you can identify a fraction circle or tiles and know what the fraction number that it is that goes with it. It'll just be with one player, but that's still fun. Okay, so here's the first one. I think that's 1/3. Let me see what's next. Oh no, that looked like 3/4. Let me try another one. 1/3. Wait a minute, I think I've heard of 1/3 before. Wasn't it right here where I saw 1/3? Yes, I got one. This is the game of concentration. I don't want to forget that this was 3/4. Let me try another one. That looks like 1/4. Okay, that's the digits, the 1/4. And this is 1/4 as well. So hey, I automatically got it. So I've got 2 points right here. Okay, so let me take a look at this one. 1, 2, 3, 4. So is it 1/5 for that one? 5 pieces, one is shaded in. That's 4/5. Okay. A half. I'm pretty good at halves, but I have not seen a half yet. Have you? Here is a half. So I got another one. Do you get the gist of it? We're trying to match them, match the fraction with the pictorial. So wasn't this one 1/5? That may have been it. Let's check it out. Let's check this one out. 1, 2, 3, 4/5. And I think this one was 4/5. Got another one, which leaves me with 3/4. So yay, I got another sock up there. I would like for you to please play this game. It's a lot of fun, and it gets you to, it's very basic, but it gets you to practice your fractions. All right, boys and girls, so we are now at the last part of this lesson, and I'd like for you to please do the cool down for today. The cool down involves you looking at 3 different fractions like we have been doing. We've been looking at comparing 2 different fractions to see if they're equivalent. So now it's going to be your turn. You're going to go to your teacher's Google Classroom math page. You're going to look for today's lesson. You're going to watch this video, you're going to play the game and answer some questions, and then you're going to do the cool down. The cool down involves you to look at the fractions and to write words in complete sentences, and you're going to turn that into your teacher. So Good luck on today's lesson. You will do great, and I hope that you are able to look and check to see which fractions are equivalent. They are the same size, same portion, same value, but not necessarily the same numerator and denominator. Have a great day, Tigers.